Okay. All right. Where did we last stop last night? Can someone recall? Where did we last stop? Tanika, where were we? Question which homework
Sir, I
set?
finished the just we were to do the I remember the question. I don't know the question number. There was one.
I have it. Like the bomb explosion, we did that, right?
Yeah, we did that one, and
Okay,
then
all right. The one after that. So it's question 8 in homework. Homework 4. Box of 2015. Blah blah blah. Which is either red, yellow, blue. Blah. Okay. Ensure that at least one of each color. We need 1979. Find the minimum number of balls to ensure 3 balls of different colors. All of you are able to see the screen, right? Okay, good. Yeah, let's start with Arnav, maybe. Arnav, Moksh, I don't see you. Turn on the cameras, please. Arnav, were you able to do this one?
No, I didn't have time. I was out. I couldn't do it.
Okay. Siddharth?
So I've done homework 5 because I've not done homework 4. So
Okay, you didn't finish the last few in homework. Okay.
Yeah.
All right. Dipra?
I did it, but I got like 1905 and the answer is 1805.
Okay. What does the answer scheme say? 1805, is it?
Yeah, and I got
So even I got 1905.
Okay. All right. 1905 is what multiple people got. Okay, let's so could be that some of the answers are wrong. So I'm not saying. Did anyone else get the thing that was mentioned in the answer scheme? Anika, what did you get?
sir, I wasn't able to do this one.
Okay, all right. So let's do this. Box contains 2015, red, green, blue, yellow, or white. So there are 5 of them. To ensure one ball of each color, we need to draw 1979. Sorry. Okay. So what is the worst case? The worst case happens when you need to withdraw 1978 balls. Okay. Where 4 colors are distributed. Okay, so sorry, I'm not explaining it very clearly. Okay, let me just give an example, right? So let's say 1978, there are 4 colors, right? Red, blue, green, yellow. So let's say there are I don't know, 600 of this, 600 of this, 600 of this, and then 178 of this. Okay, and then what is the balance here? 37 of this. Okay, let's assume the scenario is something like this. In fact, why should we keep all of them as 600? Let's keep slightly different, right? So let's say 590 either side of 600, just to say that it doesn't have to be. So let's say there are 590 of them, 610 of them. Okay, I'm trying to add up these numbers. 1800 plus 178 is 1978. So the worst case could be that as we keep drawing, we are getting denied in getting a white ball. So 1978 attempts, we are still in the first 4 colors, and therefore we need to go for the 1979th ball to pick a white. Okay, so that's what it means. In other words, the first statement gives a clue of how many there are left in the minimum color. The minimum color is, I mean, plus 1 extra that you have to add, right? So 1978, you subtract from 2015. So there are 37 of the minimum category. Let's say the minimum category is white. Okay. Now find the minimum number of balls that need to be drawn to ensure 3 balls of different colors are taken. So same logic. So let's say in this example, I said 600, 590 and all that. So we can also have a distribution where the minimum is 37. And let's say that 37 occurs here. There are 37 whites and 37 reds. And let's say 37 of this blues. So blue, red, and these are 37, 37, 37. Yeah, correct. And then the rest are distributed. So what is 37, 37, 37? If it's 1, 1, 1, right? 37, 37 times 3 is, yeah. So if you subtract that from 2015, what do you get? 1904, right? 1904. Okay, so 1904 are distributed in some way between these 2. And therefore, yes, you're right. So it's 1905 that you need to withdraw to ensure 3. That's what people got, right? Not 1805, but 1905. Yeah, you're right. Does it make sense? Whoever did not attempt it, is this clear? Yeah. Sorry, Anika, what did you say? You said you also got the same thing, or you said something? I forgot what you said.
Did not do this one.
You
I
did not do this. Okay. 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 That was question 8. Question 9. After rearranging, blah, 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 what is the maximum K? Ritisha, what did you get maximum K?
I got 6.
6. Okay. Anyone else? Same. So obviously it's best to keep the zeros at the very end. And then we have, how many? We have couple of 5s. We have a 2. We have a couple of 1s. So we can put 125. 125. And then nothing much we can do with the other. Maybe we can put 15125. Will that help? Maybe it might help, maybe it might not help. So how much? So this is 5 cubed into, there is 5 cubed into 2 cubed. So if you divide by this, what do we get? If we divide 15125 by 125, right? So 15,000 will go exactly, because there's 8 of them in each 1,000. So there are 8 of them in each 1,000, and there are 15,000s, therefore 120 of them. And then we have another 3 more, right? Sorry, we are dividing by 125. So we have 121 into 125. So this number is 121 into 125. So all I'm doing is just to check if there's any other extra 5 buried in it. It's not. So it's 121 into 125 into 1,000. Okay.
The question.
Yes. Moksha.
How would you prove this arrangement, specifically 15125? Like, I get the zeros at the end.
Mhm.
How would you prove that this arrangement of the first 5 digits is the optimum?
Yeah, it's a bit of, so we know the powers of 5 end in 5, 25, 125 or 625. And then
Yeah.
it's back to again 125, right? So
But
that
it doesn't necessarily have to be a power of 5. For example,
it has to be a power of 5,
number
right?
375.
Mhm.
375 is divisible by 5 raised to 3, but it doesn't end in 125, 25 or any things.
Correct. We want to have maximum number of 5s, right? So 375 is not a power of 5, okay? But
So, but the question
is,
isn't asking for powers of 5. It's asking
Yeah.
for numbers with like optimum.
yes, it is. It is. But if it is not ending in a power of 5, then we know that it is at best a previous multiple power of 5 times something, right? It cannot be that it's not a power of 5 itself. So it's either a power of 5 or it's a power of 5 and a multiple of a power of 5, which does not
Agreed.
have any more 5s in it. Does it
Yeah.
make sense?
That makes sense. But
Okay.
then how would we, for example, if it's a multiple of a power of 5, it can have an ending that isn't 25, but it can still have, the power of 5 that's a factor of it can be 5 raised to a very large number. Like, am I explaining what I'm trying to say about?
No, not really. Okay, all right. Okay, maybe we can do this, right? So suppose it's ending in 125 or ending in 625, one of these two, right? If I take any multiple of this, what are the possibilities? It ends in okay, an odd multiple of 125. So 1,000 is clear.
Yeah, yeah.
So an odd multiple of 125
That's
can
right,
end
in
in
25 or
125 or
75.
375, or which is the other possibility?
No, it's only 25 or 75 if it's not multiple.
No. The last, so if you have 125 times 3 is this, 125 times 5 is this, 125 times 7 is how much? 875.
It's 25, 75 only.
Yeah, so it's 125 times 7 is 875, right?
That is correct, yeah.
Yeah, so even if it's a multiple of a power of 5, and that multiple is not a power of 5 itself, or does not have any more 5 in it, it has to end in either 375 or 875. None of this is happening here, right?
Yeah.
And doesn't that suffice?
Yeah, that makes sense, yeah. Thanks.
I know I'm still not very convincing.
No,
but
I
yes.
think it makes sense. Yeah.
Yeah, but good question. Yes. Okay, so that is 9. 10. Moksh. Okay, given you're here. Okay, Moksh, what did you get on 10? How
Give me
many?
1 second. Give me 1 second, please.
4 or more positive.
I didn't get this out.
Okay, Siddharth. Oh, Siddharth, you said you did question the next homework. Sumair, were you able to do this? Question 10. I don't see you, Sumair. Camera on, please.
Yes, just
Oh,
give me.
sir, I got it. Sir, I got it. I got it.
Hold on 1 second, Moksh. Sumair was telling something. Yeah,
Okay,
Sumair, you're
so-
saying something?
Yeah, so I think I knew the method to this, but I didn't exactly solve it. Like I think
That's fine.
number
Yeah.
3 factors are the ones that are like a prime square or something like that.
Correct,
That's-
exactly.
Yeah.
How many of yeah, so so that's right. And Moksh, what was your answer you said?
No, that was the exact same method.
Okay, but you didn't finish off with an answer. Anyone has an answer? Does it match with the answer scheme that I had given?
I got 1698.
And was that
96.
okay? Let me just open up the answer scheme here. Maybe some of the answers are wrong also, like we just saw. 1 sec. This is homework for 1696 is what the answer scheme says. Okay, all right, let's see. I'm not too convinced now with this answer scheme, given there are mistakes. Fine, let's do it. Yeah, back to what Sumer was saying. So prime numbers have 2 factors. So prime is 2 factors. Prime square is 3 factors, right? Prime square is 3 factors. If you have p power 2, it's 3 factors. And then the number 1 has 1 factor. Okay, the number 1 has 1 factor. And these are the only things, right? Everything else is 4 factors. So we just have to subtract from 2017. There are 306 of them. There is one number called 1. And then how many prime squares? So we have lists the prime. So 45 square is 225. We just have to count the number of primes before that. So it's 2 square, 3 square, 2, 3, 5, 7. Okay, in the first 10. And then we have 11, 13, 17, 19, and then 23, 29. Call out, please, if I miss something. 31, 37, 41, 43. Okay, so 4, 8, 10, 12, 14. Am I right? Okay, so 14. 4, 8, 10, 12, 14. Okay, so 14 of them and 306 of them and 1 of them. So subtract so many of them. So how many is this? 321, right? So this is 321.
1696. So
It's working out.
yeah, like
Okay.
the others.
Okay, so 1696, is that the answer? 1696, right? 1696, yeah, correct. Sorry, someone said 1698 or 1697. Was that because of missing out the 1?
Yeah, so I missed out 2 factors.
Okay, I can understand missing out 1. Why missing out 2 though?
I missed out 23 and 1 more, I think.
Oh, but you counted 1 as in 1. So it's easy to forget the 1, which is neither prime, so it won't fit in
Yeah,
this
I
category.
missed 1 and 23.
You missed a 1 and 23. Okay, the number 1, which is easy to miss. Number 23, yeah, should not have missed. Okay. Okay, so that was question 10. Let's go to the next. Oh, no, actually, there's more questions, right? Question 11. Alpha, beta. Rahil, were you able to do this? Question 11.
So I actually found the roots manually and did it. I got 1.
Found the roots manually and did it. Okay. Maybe it is not so difficult. They are imaginary roots, right? In this case.
Yeah.
Okay. And what is the answer? Does it match with what was
I
given?
got- yeah.
Answer was given as 1, right? Okay. Anyone without finding the roots?
Sir, I did it without.
Yes. Go ahead, please. What did you do, Anika?
So so since we know alpha plus beta is equal to 3 and alpha times beta is equal to 7,
Yeah.
in the expression that we have, you substitute 3 with alpha plus beta, so then you'll get like alpha square plus 2 beta square plus alpha times alpha plus beta plus 4. So then if after some algebraic manipulation, like you group the like terms and like you get 2 times alpha plus beta the whole square minus 3 alpha beta plus 4. So that
Okay. All that is taken, but how did you manipulate? Can you walk us through how you manipulated, please?
so
Clearly through sum of roots and product of roots. Okay,
Yeah,
but yes.
instead of 3, just substitute alpha plus beta and then expand it, and I'll just tell you what I did after that.
Instead of this 3, is it?
Yeah. So instead of 3, you substitute alpha plus beta in place of 3.
Mhm.
That's the sum of roots. And then when you expand it, you'll get alpha square plus 2b. Yeah.
Okay, so you did this, and then you got alpha square and another alpha square. Therefore, you got 2 alpha square. Once you have 2 alpha square and 2 beta square, then we know it's symmetric, right? We can write alpha plus beta whole square minus 2 alpha beta, all that. Okay, is this clear? I want to show another method, but just to complete what she did, she spotted that this 3 is your alpha plus beta coincidentally, and therefore she went along and then she got alpha square and alpha square here. So she got 2 alpha square and 2 beta square. Once it's symmetric in alpha and beta, now it's no problem, right? So we can add extra like alpha plus beta whole square minus 2 alpha beta and all that and finish it off. What I was thinking was, see, alpha and beta are roots of this equation, which means alpha square minus 3 alpha plus 7 equal to 0. And similarly, beta is also an equation which solves this. So I can replace alpha square as 3 alpha minus 7, right? So 3 alpha minus 7. And similarly, beta square I can replace with 3 beta minus 7. Okay, so let me do that. So alpha square, I'll replace alpha square with 3 alpha minus 7. So 3 alpha minus 7 plus 2 times beta square, which is 3 beta minus 7. And then we have another 3 alpha, and then we have 4. So we have 3 alpha, 6 alpha, and 6 beta. So 6 times alpha plus beta, and rest are just numbers, right? So let's see, minus 7, minus 14, plus 4. And alpha plus beta is 3 here. So it's 18 minus 7 minus 14 plus 4. Hopefully it'll add up. 18 plus 4 is 22. 22 minus 21 is indeed 1. Okay, either way, any manipulation is good. Dipara, you were able to get this as well?
Oh no, I wasn't able to get this.
Okay, but does it make sense? Both methods make sense?
Yeah, makes sense.
Okay, cool. Question 11. Question 12. Rahil, it's good that you're able to do it using complex numbers and you showed grit in solving it. But obviously, it's much easier with this, right? Does it
Yeah.
make sense to you, Rahil?
Yeah, it makes sense. I got it.
Okay, cool. Anyone for this question? Integer, greatest integer function? Arav?
I didn't get this.
Okay, Moksh, how about you?
Yeah, I actually did get it. I didn't get the final solution, but I got the method.
Okay. All right. Anyone with a final answer? Solution? Anika?
I got this one.
Okay. What is the answer that is given again? 2 answers, 2.75 and 3.25.
The sum is 6.
Sorry?
The sum will be 6.
The sum will be 6. Okay. All right. Anika, you want to share your method?
Yes, so so here like since it's the floor function, x can lie between like x will lie between like 2 integers, so 2 consecutive integers like and k plus 1. And then you can substitute like if you have if like instead of floor of x you put k, because k like x is greater than or equal to k and less than k plus 1, and then you'll get bounds for k, and you can then wait, I'll just
Yeah. Understood. Okay. Yes. So fine. Very similar. I'll do what you did as well. Okay. So let's watch. So basically, she's saying x is a general real number. It's between an integer k and integer k plus 1. So k is an integer, right? K is an integer. Okay. So which means this mod of x, not mod of x, floor of x is k, right? So it just becomes, so x itself, she's trying to find bounds. The only one problem there is your you're assuming the bounds will happen when X is either at this boundary or at that boundary. What if it reaches a peak somewhere in between?
Yeah, no, that will that we're not really we don't need to worry about that, because once you substitute k in the original equation, you get that x is equal to 2k 7 plus 2k by 4. So you can substitute that back into your original like in inequality for k and k plus 1, because that has to hold true for
Okay.
all.
All
So
right. So
I found it easy if you do it the other way around. If you do 4x minus 7 equals 2k, and then 4x minus 7 over 2 equals k. And since k is an integer, you know 4x minus 7 over 2 has to be an integer. Then it's easier.
exactly. Yes. That was what I was going to propose. So yeah, Anika, I'll just come back to what you did as well. So, but what Moksh was saying is, so let's say x equal to k plus some epsilon, right? So I'll just say e, right? So e is definitely between 0 and 1. Okay. So we can just literally solve 4 times k plus e minus 2 times int of x is just, so int of x is just k equal to 7. So I have, I can solve, so 2k, so 4k minus 2k is 2k minus 7, or rather 7 minus 2k, right? So 4e equal to 7 minus 2k, and therefore e is 7 minus 2k upon 4. Okay, so, and we want e to be between 0 and 1. If k equal to 1, no, because it's 5 by 4. If k equal to 2, we are in the bound, right? At k equal to 2, it's 3 by 4. So epsilon is 3 by 4. If k equal to 3, we are still in the bound, right? So epsilon equal to 1/4. And if k equal to 4, it does not work out because epsilon becomes negative. So given k and e, you know your x is just the sum of these two. So it's 2 and 3/4 or 3 and 1/4. Okay. Now, what she was saying, she's trying to solve the extreme cases. So if x can be either k or at max k plus 1, so she'll solve the two extremes. We know
No, no.
int of, no, not that, sorry.
Yeah, so what I did was the 4x minus 2k equals 7, because like I'm not bringing the two different k.
Okay. Maybe I didn't understand what you, okay. So 4x minus 2k equal to 7, okay.
And then x is equal to 7 plus 2k by 4.
Yeah.
This has to lie between k and k plus 1, and then like just put it in the original inequality.
Okay. So this 7 plus 2k by 4 has to be between k plus 1 and k. Okay, very good. Okay, so 4k less than or equal to 7 plus 2k. I think it will give the same inequality pretty much. Or if I subtract 2k in this side, so it'll give a, so how do you proceed from here? Is subtracting 2k, is it?
Yes.
So 2k less than or equal to 7 less than or equal to 2k plus 4.
Yeah.
And then what
So
did you do after this?
Less than or equal to 7 by 2, and k is greater than 3 by 2. So
Okay, you solve this. Okay, this, so k is greater than or equal to 3.5. Okay, sorry, less than or equal to 3.5. K is less than or equal to 3.5. And then k is greater than, how much is this?
1.5.
1.5, okay. And then therefore k has to be either 2 or 3.
Yeah.
And then therefore you can infer what your epsilon is. Yeah, makes sense. Okay, both methods clear to everyone. Sorry, I misunderstood what you first said, Anika. Yeah, both are equally fine. But yes, my inclination is more towards what Moksh also proposed. I mean, it's literally the same thing. Okay, so maybe I just felt this was little less calculation instead of having two inequalities and all that. Okay, but makes sense, right? Both methods make sense to everyone. Arab, you're okay. Also, not Arab. Arab is my other batch. Arnab, you're okay. Okay, so that was question 12. Was it the last in this paper? Yes, it was. So let's take the next paper, homework 5. Okay, Siddharth, I think you said you did this homework, right? You want to start off with the first one? What did you get in the first one?
So I started with the first one, but I couldn't get far with it. The first question.
Why? It was fairly okay, right?
So I think there's a reason why, because according to the answer scheme, the answer was 45.
Mhm.
And if you look at the question, it refers to the ratios of AB, BC, CD. If the answer is 45, that means it has to be referring to the ratio of arc lengths. But the question makes it seem like it's referring to the ratio of segment length.
But the ratio of the segment length is same as the ratio of arc length too,
No.
right? Oh, no, okay, no,
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 yeah,
no, no,
yeah,
no.
yeah. It's
With
yeah,
segment
it
length,
is not,
it's
it is not.
possible, but it's a lot tougher, and it's not
Yeah,
an
yeah.
exact answer.
Correct. Yeah, with segment length, obviously you have trigonometric ratios. The arc length is AB r theta, and therefore arc length is proportional to the angle at the center. Was that the confusion you had as well?
Yeah.
so-
So personally, I solved it first using the segment length, and Rahul solved it using the arc length. And when we checked the mark scheme, it was the arc length that the question meant.
Okay. Siddharth, what were you saying? Sorry, I didn't understand you so fully. What did you say? You said you did with segment as well.
Yeah, that's why I got lost.
Okay, all right.
Sir, in this, like, I don't think you even need any of the ratios that have been given.
Okay. Without any ratios, how will you do?
So, so like if you know that triangle ACE is a right angle triangle and OA is a radius. So, like, since it's the radius of a right angle triangle, it bisects, it's also the median and the altitude. So then you get that angle COA is 45 and OC is equal to OA because they're both radii, and then you get
But A can be literally anywhere, right? So in the sense, I agree this is 90 degree, but A could have been somewhere here, like for example, right? A could have been here.
but it would, it won't be the it won't be the median. It'll be the median, but not the. Okay, just a minute.
That some ratio of the angles is not needed because I agree that this part is definitely needs to be clarified. It's arc length. Okay. But if that is assuming this is not given at all, then I can draw a diagram like this where this is still 90, but then clearly ACE I can show you an angle which is less than 45, right? Does it make sense, Anika?
I actually did use the ratios. I forgot.
Yeah. Fine. But yes, to your point, or if you don't need the ratios, I don't think that's right. You do need the ratios. Agreed? Okay. Rahil, you had a doubt? Or
What if the question was chord length? Then how do we do it?
then obviously it becomes very complicated because chord length is related to the angle.
So it's not that bad actually. Should I explain?
Theta, right? Sorry?
It's not that bad actually. Should I explain?
Yeah. So essentially it becomes with trigonometry, but yes, you can explain it. But before we proceed with the angles, it's all clear, right? So it's 45 degree. That part is easy, right? All of us are okay on that one, right? So this is 2 theta, I think, and this is 4 theta. And the 4 theta comes out to be what? 6 theta is 180, the 4 theta is 60, I think, right? And then once you know one angle,
that's correct.
everything else comes out. Okay. Yeah. Now, go ahead, explain Moksh with assuming they are chord lengths. What did you have to do?
Yeah. Okay. So first we construct lines AB, BC, and CD.
Okay. Let me just draw it. AB, BC, and CD. Yeah.
If we take AB as 1, BC as 2, and CD as 4, like you can just take it as that to scale up and down.
This is 1, 2, and 4. Yeah.
Yeah. Then we can use Pythagoras in triangle BCD and its right angle. So we know that DB is 2 root 5. And
2
the
and
radius
4,
is
therefore
root
2
5.
root 5. Yeah. So this is 2 root 5, therefore this is root 5. Yeah.
Yeah. Then if you look at triangle AOB, you know all the sides, so you can find angle AOB. Then it's just cosine law. It's annoying to work out, but it's not tough.
So okay, so this is how much? This is the root 5 as well. Okay. Now AOB, you're saying I can figure out this angle using cosine rule.
Arc cos 9.10.
Yeah. So using cosine rule. Rahil, you're with me as well, with him as well on this.
Yeah, I got it. Yeah.
Okay, and then you can do 90 minus this to find this. Or in fact, why even go that far? What do we want? ACE. Where is E?
So what I did is I found BOC, then I used the cos addition formulae, and then I did 180 minus that over 2 because it's an isosceles.
wait a second. To find ACE, why do we
Yeah.
have to do so much? Because we don't know this is 90, is it?
Yeah, exactly.
Ah, okay, I see. That I was okay, and then just 180 minus this divided by 2, right?
Yeah.
180 minus this divided by 2. Okay, all right. So this is how much this is come out to, by the way? You said cos theta was
There's
how
no
much?
exact answer.
No, that's
It's
fine. Just approximate. So
90
cos theta
minus
is 5
cos
plus.
inverse 27 minus root 190 over 100.
So a square plus b square minus 2ab by
The
this
second
right?
one is arc cos 6 over 10. Angle BOC is arc cos 6 over 10.
What am I doing wrong here? A square plus b square minus 1 by 2 into 5. 9 over 10, right? Isn't it 9 over 10?
Yeah, angle AOB is 9 over 10. Angle COB is 6 over 10.
COB is 6 over 10. Okay, I see. By the same logic. Okay, fine.
Yeah.
So that will be 5 plus 5 minus 2 by 2 into 5. 8 over 10, you mean, right?
There is a possibility I messed up.
5 plus. No, you're right. 6 over 10. Okay, 6 over 10 and 9 over 10. And then you can add both of these angles and 90 minus that. Yes, understood. Yeah. Okay, it's interesting that we can still do it, right? Maybe it could be another problem for another day. So cos inverse of 9 by 10 plus cos inverse of 6 by 10. Oh, by the way, cos inverse of 3 by 4, 3 by 5, it's like the 30, 60, 90, not 30, 60, 37, 53. So it's 37 degrees and 53 degrees. This is what approximately, not exactly. So if you want to do some approximation, cos inverse of 3 by 5 is what, 53 degrees. So this is approximately 53 degrees.
So is it
Yeah.
by chance 37.5? Because that's 3 over 8.
It's 37.1. It's not
Oh,
exactly
okay.
37. In fact, it's
Okay.
not a round number at all. 37.1 change. And I think 52.9 change, something like that. I don't remember the exact thing. But first approximation, this is good enough. So this is, I'm just trying to see how close it is to 90. That's all. So this was 53 degrees. Instead of, in this problem, it was 60 degrees. And then if I have to do cos inverse of 9 by 10, that's little hard. It's easy to do sine inverse. So if cos theta is 0.9, then cos square theta is 0.81. Therefore, sine square theta is 0.19. And therefore, sine theta is square root of 0.19. So we know that 0.2025 is 45 square. So it's around 0.42, right? So sine theta is 0.42. And that will help us guess by 2. So we know that, again, if you want to guess at all. So sine 30 is half. So it has to be slightly smaller than that. And we know that sine theta for small theta is more or less like linear. So for 30 degrees, we get 0.5. So if you're around 0.42, then that's around 80% of it. 80% of 30 degrees is 24 degrees. So can someone do, if sine 24 degrees close to 0.42, if you have your calculator up, just check if sine, just check sine inverse of 0.42 and see how close it is to 24 degree. Can someone?
It's 24.83.
24.8, is it? Okay, so it's substantially off, 25, okay, almost. Okay, but at least for approximation, 24, 25, and then 53 plus 25 is how much? 78 degrees. So quite off from 90 degrees. Nice. Okay, yeah, sorry, Siddharth, that you had to struggle, but obviously there was learning in this. Good. It's arc length. Question 2.
So I got this fairly easily. 58.
58. Okay. No, I was actually going to ask someone else to call out the answer, but that's fine. You did.
So
Okay.
that's long. Oh, second smallest. I apologize. I think that's correct.
Yeah, second smallest. Okay. Dipra, were you able to do this?
Yeah.
Okay. What is the logic? Can you share?
Yeah, so what I did was so for this I tried to get like another link between X and Y, basically using the 3 pairs. And
Mhm.
after finding the second link, so I don't have my working here, but like after that it was like you could just compare the two and it was pretty straightforward.
Okay. Okay, that's fine. Siddharth, can you share your working? What did you do?
So I don't know if this is right or wrong, but I tried to find the first smallest one for a square minus 2b square is equal to 4, and that came out to be 6 and 4. So that was like double of 3 and 2. So I
Mhm.
thought if they've given that, there's obviously some link there. So I did 17 plus 12 into 2, 29 into 2, which is 58.
Yes. And the link is very
Should I
easy.
explain?
Yeah. Yeah. Go ahead. Explain the link, Moksha. Yeah.
For the first equation, x squared minus 2y squared equals 1. You can multiply both sides by 4, and obviously the solutions will be the exact same. 4x squared minus 2 or minus 8y squared equals 4.
Yeah.
And then you can
scale-
just substitute a equals 2x, b equals 2y.
Exactly. So take the first equation, scale every x by 2, scale every y by 2, and therefore the right-hand side gets scaled by the square of 2, which is 4. And therefore, 6 and 4 was the first one, 34 and 24 was the second one. Okay. Makes sense. But suppose it is not given, even then you can still solve. So assuming this first information is not given to you at all, all of this is not even given to you, you can still solve it pretty decently, right? So I can write this as a square minus 4 equal to 2b square. So which is a plus 2 times a minus 2 is 2b square. Okay. Now, if you look at a plus 2 and a minus 2, for getting small numbers, for small numbers, obviously this might not be true, but as you go slightly bigger, they cannot have any other common factors other than 4 and factors of 4, because they are apart by 4. For example, they cannot have a common factor, which is 7, for example, because they are apart only by 4, right? So the maximum common factor they can have is 4. And of course, when you say 4, obviously 2 and 1 as well, right? Now, so the only possibility for numbers which are larger than, let's say, single digit numbers is that one of them is a perfect square. So we need to have this product to be a perfect square, right? 2b square, right? A square minus 4 is 2b square. Okay, so one of them has to be a perfect square, and the other one is 2 times another perfect square. So I'll write this as 2 times m square times l square. Okay, so one of them is maybe m square. The other one is 2 times n square, or reverse. This could be 2 times m square and this could be n square. Okay, one of the two. Are you guys convinced with this, that only then the product will become 2b square? Ritisha, are you convinced?
Yes, sir.
Yeah, you are, right? So now, and then it's obviously an even square here, right? So it is an even number, right? So both numbers must be even. So we can start searching even square. So for example, we can assume that this is forget 2 square. This is 16 and this is 4 more than 16, or this is 16 and this is 4 less than 16. So let's say, so if it's this case, it's 20 divided by 2 a perfect square? No, it is not. Is 12 divided by 2 a perfect square? No, it is not. So that does not work. Okay. So next we go to 36. So can this be 36 and the larger number? So this is a plus 2 and this is a minus 2. They are apart by 4. Will this work or will this work? Okay. This one may not work because 40 divided by 2 is not a perfect square. This will work because 32 divided by 2 is a perfect square. So we can have 36 times 32 being 2 times 6 square times 4 square. So, or rather, so my m is 6 and n is 4. Okay, therefore it works out as 2b square. Okay, and I think that's what is happening here, right? So you get your a is therefore in between a plus 2 and a minus 2. So a is your 34, a is your 34, and b is your what is the b that we got? We got m into n, right? So b is the mn, which is 24. So 34 plus 24 is 58. We still get the same answer without using the information that was given. All of this without giving this. But yes, with the information given, you can directly see the scaling works. Yeah. Cool. So that was question 2. Question 3. X square minus y square should be fairly easy, right? How many sets do we have? Rahil?
3.
Rahil, 3, right? So
Yeah.
just finding the prime
Difference of
factorization of 23. So this is 17. I think I remember 7 times 17 square, if I remember right. So it has
That's that, yeah.
6 factors. So 6 factors. And therefore, you can write them as x plus y times x minus y. So anytime you write it as a product, a times b, right? The smaller one you have to assign to a x minus y. The bigger one you have to assign to x plus y. So there's 3 pairs. And for each equation you solve, you'll get one unique x. And you don't have to solve and waste time. All we need is find the number of solution sets. Therefore, it's only 3 sets. Arav, you with me on this one? You got this as well?
Yes.
Okay. Question 4. Arav, what did you get on question 4? A1, A2, blah, blah, blah.
I didn't get this one.
Fairly easy one, I thought. Sumer, did you do this one?
So I started, but I think I knew it, so I didn't do it.
Okay. Siddharth, what about you? What did you
Yeah,
get?
sir, I got this. I got the correct answer. 8.
8. Okay, so it's 20, 23, and an plus 2 is the subtraction of these two, right? So
That'll
it's
be 3.
3,
The
and
minus
then
20.
minus
yeah.
20, minus
And
23,
I
and then
went-
the
I-
pattern
Yeah,
continues.
I went until A11 because the mean of that will be the 10 A10 plus A11 upon 2.
You don't even have to do that. Okay, so now after this, the pattern repeats, right? Minus 20, minus 23, and then minus 3 minus 23 is 20. So we know it's back to the same 20, 23, and 3 business. So every 6 things are getting cancelled out perfectly, right? So by the 18th term, the sum is 0. Okay, so the 19th and 20th term are going to be the first two, 20 and 23. So S20 is nothing but the 19th term and the 20th term. So every 6, the pattern resets to 0. The sum resets to 0. Therefore, it's 43 is the sum. And the average, I think, right? Find the sum of all digits of n, where n is the average or is the...
So N is the average, yeah.
It is average. Okay, yeah. So 43 divided by 2, which is 21.5, and therefore 2.15, sorry. Okay, therefore it's 8. Okay. Yeah, maybe Siddharth, you could have saved maybe 10 seconds by avoiding sum of terms in a arithmetic progression. Or maybe not. Maybe it was equally efficient. Sorry, just 1 second, guys. I'll be back. 1 second. I'll get some water. Okay. Question 5.
So just a question. In
Yes,
the
yes.
third question, how did you come to know that there were only 3 pairs?
Because there are only 6. There are only 6 factors. So which means, let's say A, B. So let's say 1 into 2023 would be the first one. 7 into 17 square is the other one. And then whatever, 17 into 119. 7 times 17 is 119 is the other one. So we agree we have finished all the possible factors of 2023. And each of them, when you solve, I can set x minus y to be the lower one, x plus y to be the higher one. Each of them gives a unique solution.
Okay, fine, got it.
Yeah.
Yeah.
Question 4. Question 5. Question 5, did I copy this? Okay. Arnav, question 5. Arnav, your camera is off, beta. Turn on the camera. What did you get?
Oh, I didn't do this worksheet.
You didn't do the worksheet itself. Okay, all right. Yeah, Rahil, were you able to get this one?
So no, I didn't get this.
Okay, Dipra,
Get this one.
Okay, Moksh, what did you do?
Okay. So my
Actually,
answer.
Moksh, maybe you answered, but Anika, can you take this one? Yeah.
Yeah, so in this I got 142, which is, I think it's the correct answer. So I did 20x minus, so I identified that 23 is like 20 plus 3, so I could do 20x minus 20y equals 2023 into plus 3y. So so 20, the left side is a factor, is a multiple of 20, so we have to find the smallest like next multiple of 20 such that, so it's 2023, not 203. And then such that 3y, such that y is an integer, so then you'll get that the closest one is 2080, which will give y equals 19, I think. Yes, and then I just,
But that will give the minimum value possibly for x minus y. You want the minimum value for x plus y, right?
so
That it's very similar. All you have to just do is just change a little bit. So 20x, make this 20x plus 20y minus 43y equal to 2023. So this time this becomes 20 times x plus y equal to 2023 plus 43y. Now we exactly want this quantity to be minimal. So this way we'll know that whenever we reach our destination first, we are done, right? So which multiple of y will give me, right? You understand what I'm saying, right? But in fact, what you are saying is also fine, because what, no, maybe not fine. Maybe this may not be convincing, because you're also searching for the y, the next possible y when that happens, but that will have the smallest possible x minus y, which means the y that's resulting there could be bigger than what you want, right? Are you convinced with my argument?
yeah.
Okay, so it's better to write in terms of x plus y, because that's what we are trying to minimize. And once you write it in this pattern, now it's easy, right? We just have to experiment. So basically 43 times 9 will end in 7. 3 times 9 only will end in 7, right? Nothing else, right? 3 times nothing else ends in 7. Yeah, so we can keep trying 43 times 9, 43 times 19, and so on, and soon we'll hit a multiple of 20. Okay. Sorry, Moksh, you were saying, were you also doing something similar?
I used a similar method, but it was a bit different.
Okay.
What I did was 20x minus 2023 equals 23y.
So sorry, Moksh. Before you explain, let's finish this for completeness. Okay. So
Okay.
so we are clear on this portion, right? So 43 times 43y, 3 times 9 only will end in 7, right? 3 times nothing will end in 7. Yeah. Okay. So for 43 times 9 will be how much? 9 3s are 27. 9 4
I think
387.
it's times 19.
19.
Times 9 doesn't
So
work.
9 does not work. And then 19, hopefully 19 times 3 is 57. 19 4s are 76. 817. So 817 plus 023 will end in 840. So which is a multiple of 4, right, sir? And there's a 2 before this, right? 2 before this. So 2840 divided by 20 is our answer, right? Which is 142. Yeah, Moksh, you were saying? Go
I
ahead.
used a slightly different method. I used like the traditional way of solving these linear Diophantine equations.
Go ahead.
What I did was 20x minus 2023 equals 23y.
Okay.
Then 20x minus 2023 over 23 equals y.
Yeah.
Then we know, I figured out x has to be in the form 9 plus 23k to be an integer. And then that gives all possible solutions. And I just found the smallest possible solution, which gives an integral y.
Sorry, x has to be, say that again, x has to be?
In the form 9 plus 23k to give an integer solution.
9 plus 23k. 23 is to avoid this 23. Why 9?
No, like I just found out, like if x equals 9, then y is an integer. And then if x equals 9 plus 23, y is also, like this is just all possible solutions.
Okay.
And then I found the smallest possible solution.
Okay, I see. So I see, but And with how much trial did you have to go through to get
No,
this?
no trial at all. I just had to figure out an x such that
Correct. But how many
such that
loops of
20x is greater than 2023, which was I believe 123.
okay. All right. So 2023 is 9 mod 23, is it? 2023 leaves a remainder of 9 when you divide by 23.
2023 is minus 1 mod 23.
Minus 1.
Sorry, I apologize. It is 8 plus 23k, not 9. 8 plus 23k.
Okay. So you figure out whatever that remainder is, and therefore you manipulate it
Yeah.
with extra
Yeah,
days. Okay.
it's modular arithmetic. It was not as efficient as the method Anika got, but I found it like I didn't ever think as much to get this.
Okay. That's fine. Okay, good. Question 5 was that. Question 6 is straightforward, right? Siddharth, what did you do? Question 6.
So this, I tried to manually solve it, but then it got out of hand, so I just left it midway.
Oh, this should have been fairly straightforward, right? Ritisha, what did you do on this one?
I got 103, but in answer scheme it's 3.
Okay. Anyone else think the answer scheme is wrong on this one? So this is 20. So 100 can be taken out everywhere. So obviously you can recognize that 43 is the sum of these two. 49 is the sum of these two. 55 is the sum of these two. So I can write this as 20 plus 23 by 20 into 23 minus 23 plus 26 upon 23 into 26. And then I'll write one more. So 26 plus 29 upon 26 into 29 and so on. And the benefit of this is the telescopic cancellation, right? So 100 into, so this becomes 1 by 23, right? 1 by 23 minus 1 by 20. Sorry, plus 1 by 2. No, I'll write it as 1 by 20. Okay, maybe I should have written the denominator in the opposite order, but that's fine. So 1 by 20 and plus 1 by 23 effectively. And then I can write this as minus 1 by 23 minus 1 by 26. Or rather, I'll put brackets, that way it's easy. And then you can see plus 1 by 26, 1 by 29. And then you can see the telescopic cancellation. This one cancels, this one cancels, blah, blah, blah. And the last one that would be left is 1 by 50, right? With a negative sign. And the 1 by 47 will get cancelled with the previous one. Okay, so we are left with 100 times 1 by 20 minus 1 by 50. And with 100 as the common denominator, I have 5 minus 2. So indeed, it's 3. Where is the extra 100 that you got?
So I did a different method, so I don't know what I did.
Okay, can you tell me what you did, please?
So I took 100 out, and if you see, like, if you take 1 by 20 minus 1 by 23, then it's 3 divided by 20 into 23. So I took divided by 3 also out.
Okay, 1 by 20 minus 1 by 23 is 3 by 20 to 23.
Yeah, so 100 divided by 3.
Okay, and then what did you do with the 43?
So I took it in the numerators and.
Okay, and then
yeah,
this
and
numerator will again differ, right?
Yeah, and then what I saw was that it was coming plus 4, minus 4, plus 4. So all of them were cancelling out. But only 43 by 20 and 97 by 50 were remaining. So then
how will it cancel? For example, take me through the next step.
So it'll be 43 by 20 minus 43 by 23 minus 49 by 23. So if you add the similar denominators, then it's minus 4 plus 4, all of that. All of them are.
I see. So minus 49. So you wrote this as okay, let me just, so you wrote this as minus 49 into 1 by 23 minus 1 by 26, something like this.
Yeah.
But then if you do that, then 1 by 23 has a negative sign here and a negative sign here also, right?
So when you add both of them, it's minus 4. And for the others, it's plus 4. So it's plus 4, minus 4, plus 4, minus 4 for every one of them.
I see. +4 -4. Okay, okay. All right. Maybe some edge case you're missing. Can you just check your working? Maybe.
Yeah, I'll check.
Okay. Okay. Yeah, that's interesting. I never thought about it in this way. Okay, nice. Okay, telescopic cancellation. Question 7. Ritisha, question 7.
Question 7, I got 1.
Okay, and that matches with what's given in the answer, right?
Yeah.
Okay, what did you do?
You just square both of the equations and then add them, and that's all.
Yeah, add or subtract, something should work, right? So this is sine alpha cos beta minus cos alpha sine beta. So we need cross terms. So obvious thing to do is squaring them. So when I square this, I get sine square alpha plus 2 sine alpha cos beta plus cos square beta is 0.6 square, and 0.6 square and 0.8 square we know add up to 1. 3 square plus 4 square equal to 5 square. So this will become sine square beta minus 2 sine beta cos alpha plus cos square alpha is equal to this. Okay, so clearly when I add these two, I get sine square alpha plus cos square alpha, sine square beta plus cos square beta. So that's 1 plus 1. And then I have 2 times exactly what I need. Sine alpha cos beta minus cos alpha sine beta. Okay, so that is equal to 0.6 square plus 0.8 square is 1. Therefore, the answer is 1 minus 2, which is minus 1. Oh, okay, he has put an absolute value. So I don't know why he has put the absolute value and all that. So it's minus 1, therefore it's 1. Okay, fairly straightforward again. Yeah, I guess this paper was all about questions in the range 5 to, I want to make sure that you guys are completely comfortable with questions 15 and below. So I wanted to give that variety also. Question 8, first part. Let's see. Soham.
I think in this question, we should solve the second part first, and that will lead us to the first part's answer.
I don't know
Yeah,
about second part leading to the first part. Okay, Siddharth, just let me just pass it on to Soham. Soham, when did you join class? I didn't see you at the beginning. Was it in the between?
Yeah, so I just joined.
Okay. Okay. Either of the two parts. So there are people who think the second part is easier. Did you want to start with the second part or first part? I leave it to you.
I'll do the first part.
Okay, go ahead. What did you get? You got the answer that was given in the answer sheet. Okay, turn on your camera, please, Soham.
Yeah.
Yeah.
No,
The
I
answer scheme.
thought you would ask me to solve it right now.
No, not right now. We're able to do it at home or wherever, right? Now we are discussing, right? So you did not solve it at home. Okay. Yeah, go ahead, Siddharth. You want to go for the first or the second part?
So the second first.
Okay.
Because
second. Okay, second. Okay, all right.
So because when it's identical, we just need to see the number that each person gets. We don't focus on the present actually.
Okay. All right. So for the second, what do you have to do? Tell me.
So it can be like 1 2 2 2 1 2 and 2 2 1, and then it can be 1 3 1 and 1 1 3 and 3 1 1.
And that adds up to how much? That all of those cases add up to. So essentially you're saying, so 5 identical to, so basically you're saying 5 identical and 3 people. Okay, so let's say A, B, C. So basically you're allocating, each person gets at least 1. So let's say we can put this clause, let's say A is ascending order or descending order, it doesn't matter. But obviously this method will be long. I'll comment on it in just a second. But since you started off with this, let's do this. So let's say this guy gets 1 and this guy gets 1, this guy gets 3. Going in ascending order, the next one would be 1 2 2, right? 1 2 2. And that's it. Now we can go for 2 2 and 1. Yeah. Correct? Is that the one?
Yes, sir.
Okay, so this has 6 ways in which you can do this. Oh, sorry, 3 ways in which you can do this. Right? Am I missing other cases where each person gets? Okay, so 3 ways in which you can, because the person who gets 3 can be either A or B or C. 3 ways in which you can do this, 3 ways in which you can use this. So in 9 ways. Is that the answer? I don't know. 4 3 identical, 7 choose 2. It should be 21, no? What cases are missing here, guys?
Is there a way to do this using the stars and bars method? or-
Exactly. That's easier. Okay, so let's, I want to do that. But before that, I want to see what mistake he's doing to, or rather, I'm doing when I'm explaining to him. Am I missing any case, Anika? 2, 2, 1. Oh, sorry. 1, 1, 2, 2 is already included, right?
Exactly, sir.
Each, yeah, each person gets at least one. Oh, each person gets at least one. I didn't even do. Okay, sorry, guys. Okay, so for this, the answer should be 6 only, correct?
Yeah,
So the answer
that's what I was thinking.
Same, sir.
okay, so it is actually my fault. So I inserted this question and I didn't mean at least 1% each, right? So that was the case for the first part, but not for the second part. I'm sorry. My answer in the answer scheme on this one was wrong. It was my mistake. So it is 6, and we can do it in a much better way, because suppose who was that, Siddharth, instead of 5 identical presents, let's say I have 20 identical presents, and that's not say 3 people, let's say there are 7 people, then this method becomes very unwieldy. Do you agree with that, Siddharth?
Yes.
Okay, so in that, was it Anika or Ritisha who was proposing the other one, right? The star and the stick method. What is the star and the stick method? So the 20 identical presents, let's call all the presents P, 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 right? All of them are identical. So there are 20 of them laid out here. Okay, 20 presents. And then let's say there are, I'll say 3 kids, right? Instead of people. Okay, so the 3 kids, 7 kids waiting here. K1, K2, K3, and so on till K7. Okay, now you can put like sort of doors. So you can say, you can partition this and say, I can insert a door here, I can insert a door here. Let me put a bunch of P's here so that, okay, I can insert a door here, another door here, okay, and so on. 1, 2, 3, 4. Let me use 5, 6. Okay, 6 doors I've inserted. So the first kid gets everything to the left of the first door. So this gets allocated to kid 1. This gets allocated to kid 2. This is kid 3. Kid 4 gets 0. Kid 5 gets 2, 6, and then kid 7 gets a 0 as well. Okay, this would be the case when the restriction that each person gets at least 1 is not there, right? So some kids can go empty-handed. But suppose the same problem, 20%, 7 kids, each person has to get 1 kid. Then it's fine. It's still doable. We can subtract. We can give away 1% at the very beginning to all of the 7 kids, so that no one gets empty-handed. So we can reduce the problem to 13%, 7 kids, and no restriction that each kid has to get at least 1%, because already you've given them 1. On top of that, they can get 0. That's no problem. So it reduces to 13% and 7 kids, which means 13% and 6 partitions. So it's a 19-letter word. So I'll have to choose which are the 6 places where the partitions go. So it's 19, choose 6 in that case. Siddharth, does this make sense, or did I go fast on this? You're okay, right, on this one? Are you good? Okay. Now, so let's see whether we get the same answer for this problem. So 5 identical persons to 3 people, although it's an overkill. What you did was perfect for such a small number, but let's see whether you get the same answer. So each person needs to get at least 1%. So you first give 1, 1, 1 to each of them. So you're left with only 2%, right? So only 2%, and we have 3 kids. Therefore, we need 2 partitions. So you need 2 partitions. So it's just arranging a 4-letter word where you need to insert 2 places where the partitions go. The rest of the places, the presents are there. So it's 4, choose 2, which is 6. Yeah. So with identical presents, it's easy, right? Either with each person getting some minimal number, it's easy to do. We can just give that minimal number first and reduce it to the problem where that minimum restriction is not there. With non-identical presents, 5 different presents, then it becomes a little more tricky. But Siddharth, I don't think they are directly connected. So okay, I'll give it to you only. What did you do? How did you connect the first one with the second one? I didn't understand that connection.
I tried to connect it in the way that when there were only 6 methods, like 1, 3, 1, and whatever. So
No,
I
but
try.
you cannot just say 1, 3, 1, because when you say 1, 3, 1, which one, right?
No, no.
Because
So I'm expanding on that. So in the 1, 3, 1, if you see it, there are 5 different presents. So the first person can get 5 choices. The second only gets 4. And then I think since 4 of them are gone, it's 1 left. So first scenario is 20. So that is that individually. And it came up to the answer. But I think it's a very long method.
not only long method, it's difficult to keep track also, because let's say you give that allocation as 1, 3, 1. Okay, let's say the first person gets some percent, the second one gets some other 3, and then the remaining third one gets the remaining 1, right? You'll end up double counting if the allocation goes in a different sequence. Sorry, I'm not explaining it well, but I'm saying it's unwieldy. Not only is it long, so there are problems where even though it's long, it's methodical. We can definitely do it. Given infinite time or sufficient amount of time, we can definitely do it. But there are other problems where it's long and not methodical. You will have double counting and all of that to keep track of it. Okay, so that won't work. Okay, so, but let's reduce first. Let's do the simpler version of this. So suppose I don't have this restriction. So we are, first of all, we are done with the second part, right? So the second part was done and the correct answer is 6. My answer in the answer scheme is wrong. So this is 6. It's done. Now for the first part, let's modify where each person gets at least 1%. Suppose that restriction is not there. Then what will the answer be? 5 different persons to 3 people. Someone can go empty-handed, no problem. Then Ritisha, what will the answer for that one be? 5 different persons to 3 people. Kids.
1 second.
Okay, or anyone?
5p3.
Why 5p3?
So won't it be 3 raised to power 5?
3 raised to 5. Exactly. Yeah. I'll come back to the 5p3, whoever called out. So the first percent can go to any one of the 3 kids. The second percent can go to any one of the 3 kids, and so on. So it's 3 power 5, right? Which is whatever, for 243, right? But why 5p3 is what? 5 into 4 into 3, right? What is the logic of 5 into 4 into 3?
No, my bad. I was thinking order.
Okay, all right. So it's 243. Okay, now we introduce this restriction where each kid gets only 1%. Now, how do you approach? Ritisha, yeah, want to take it?
So I'm not sure for this one.
Okay. Moksh, you're around? Okay, I don't see Moksh. Anika, what about you?
Sir, entire thing, but like, so then you remove the one case where nobody gets anything, and then you remove the cases where only like 2 people get, and so then that'll be 2 raised to 5 minus 1 minus 2 raised to 5. I'll have to see that.
Exactly. The method is exactly right. Okay. So basically, of the 243 cases, we subtract cases where exactly 2 people, exactly 2 kids, right? Exactly 2 kids. I say exactly for a reason. Exactly 2 kids get all the presents. Okay. So let's say this is case A. I want to subtract case A. I also want to subtract exactly 1 kid gets all the presents. Okay. All the presents. Okay. Now, so let's say this is case A and this is case B. Case B is very easy, right? So case B, there are only 2 possibilities. 3 possibilities, right? Either kid 1 or kid 2 or kid 3 takes all of the 5 kids and goes home. So case B is easy. Case A, okay. So case A, so assume there are only 2 kids. So K1, K2, and K3. Okay. So assume for a second that K3 is not even in the picture. So I'm not even seeing this second, third kid. So I'm trying to allocate all of it to these 2. By the same logic, I will have 2 power 5 cases, but right, 2 power 5 cases to distribute all the kids, all the presents to the 2 kids. But in that, there will be 2 cases where I should take away, because what if all the presents goes to kid 1, or what if all the presents goes to kid 2, right? So there are 2 power 5 minus 2, which is 32 minus 2, which is 30 ways in which all the presents goes to kid 1 and kid 2, where between kid 1 and kid 2, each of them gets at least 1. So it's 30. And then by symmetry, it can be kid 2, kid 3, or it can be kid 3 and kid 1. So it's 30 into 3, 90. So we'll have to subtract 90 for case A and 3 for case B. So 93 needs to be subtracted from 243. So 243 minus 93, which is 150. Yeah, makes sense?
So I was doing a different method, but I don't know what went wrong in that. So I was thinking like, for the first present, you can give it to like 5 people, so 5 for that. For the
Mhm.
second present, you can give it to 4 people, and then for the third one, you can give it to 3. But
Yeah.
then now there are 2 presents left, and you have 3 people. So shouldn't it be like into 3 into 3?
Okay, so 5 into 4 into 3 is clear. Now, what I'm saying, into 3, because the second present you can give to any one of the 3.
Yeah, and the last present also.
Okay, all right. I know the mistake in this. Can anyone else spot the mistake in this? Moksh, can you spot the mistake in what she is doing? You understood, right? So these are the 5 gifts waiting here. So the
Yeah.
gifts. Okay, so I don't know how to call the gifts. I'll just call the gifts
Okay.
A, B, C, D, E.
Okay.
Okay, and the kids is P, Q, and R. Okay,
Mhm.
so she takes P. Sorry, these are the gifts, right? These are the gifts. She takes. Sorry, what is the 5 again? Sorry.
You
There
can
are
give
5
the
gifts.
first present to 5 people. No,
No, there are 3 kids here. No, there are
no,
3
yeah,
kids.
the first person can get 5 presents.
Okay, so P can get any one of A, B, C, D, or E. Okay,
Yeah.
and then she goes to Q and allocates any one of the remaining 4, allocates any one of the remaining 3, and then she has satisfied all of them to give 1 each. And now the
Yeah.
remaining 2 gifts,
Can be distributed in how many ways?
she gives it to any one of the 3 people. She gives it to any one of the 3 people.
Yeah, but the issue is I don't think this accounts for order. Like giving P, if you're giving P present A, then you give QR present BC, then you give P present D, and Q present E. Okay, this is just a completely random example.
Mhm.
This case is identical to starting off with the D as the first present,
Exactly.
and then giving A in the second round, but it will be counted twice.
Exactly. Does it make sense, Ritisha?
Yeah.
Yes. Yeah. So this is exactly same as what if you gave D here and then B here and C here, and then you gave A, E, and that's it, right? That's enough to prove there's double counting. But again, you cannot directly divide by any number to compensate. It's muddly, right? And therefore, this will give a bigger answer. Hopefully, this will give a bigger answer. Let's see. 2060. This is giving 540.
540.
Yeah. Yeah. Okay. So we did this. Next one. Question 9. Altitude. Is it? Find the. Oh, question 10 is altitude. Length of 2 sides of a triangle are 14 and 15. Find the square of the opposite sides. Okay, Rahil. How are you guys doing? I know today's class is 2 hours or so. Do you need a small break or you're okay to continue? 5-minute break? Should we resume at 4:35? Is that okay?
Yes.
Okay, all right. For 4:35. Okay, just 5 minutes. Okay, it's 4:30 right now. Okay, I'll be back as well. I'll get some coffee. Okay. Hi guys, I'm back. Are people back? Turn on the cameras. Rahil, question 9. I should have paused the recording, maybe. That's fine. It's okay. Rahil, are you back? Looks like you're not. Let's see. Dipra.
I didn't get time to solve more. I solved only till half a worksheet.
Till half of this worksheet. Okay. Let's see. Who else? Ritisha. Ritisha, you just answered the previous one, right? I'll give it to Anika. Anika, this one, 14 and 15.
Yeah, so I just got one of no, I just got one possible length for the third side, so I think I've already made a mistake here.
Okay, so let's see. So we have 14 and 15. Area of triangle is 84. So let's say 84 is divisible by 14, right? So the altitude is 12, right? So half into 14 into h is 84. Excuse me, 84.
So
Therefore,
you can
h
just use
is
sine law.
h is 12.
So you could do half into 14 into 15 into sine A is equal to 84.
Yeah.
And you get the value of A, and then you can use the cosine law to find the opposite side.
Okay. I'll pursue that as well. So, but first, let's see if h equal to 12. So let's say this is 14. This is 14, and this is 15. And this altitude is, sorry, altitude to 14 is 12, right? So I have to, let me just draw it a little differently. So this is, let's say this is 14. And this is 15. Okay, slightly longer, right? So this is 15. And so this is 14 and this is 15. And this altitude is 12. This altitude is 12. So now I can see here a 12 and 15. So that's 3, 4, 5 ratio. Therefore, this can be 9 and this can be 5. And I can find the third side, which is 12 square plus 5 square, which is 13. So that's one case. Probably, Anika, you got this case, right?
Yeah.
Am I right? Okay. But then it can be obtuse angle triangle as well. So this can be, the 14 can be here. And the 15 can be this way with the same altitude. It's messing up something here. Okay, control 6. Okay, so this is, the altitude is the same 12 here coming down, but it's outside the triangle. So this is the triangle here, right? So this is the third side. Okay, we'll do the sine rule, cosine rule as these guys were suggesting right after this, but let's complete this. Control, I don't know, my control button is a little messy. So this is 15, this is 14. And now we can have this portion as 9 by the same logic. So this portion is 9. Okay, therefore, this guy becomes square root of 23 square rather than 14 minus 9. Now it's 14 plus 9. That's the only difference. 23 square plus 12 square. Okay, so the answer is, or rather, in fact, it just happened to be a proper number, 12 square. So I'll write it as 9 square plus 12 square. So he wants the sum of the possible squares of the third side. So the answer is, we have to add the squares of these two. So it's 9 square plus 23 square plus 12 square plus 12 square. So that should come out to whatever that answer is. 529, 81, 144, 144. Does this add up, guys? 18, 1 carry, 3, 19, 1 carry, 6. Am I right? 898, is that the answer? Or was it?
I got a slightly different answer. So.
Okay, what is the answer scheme answer, please? Does anyone have it?
742.
742. Am I doing something wrong here? 9, 12, 5, 12, 13. Oh, 9 square plus 12 square. Sorry, this is 5 square plus 12 square, not 9 square plus 12 square, but 5 square plus 12 square. So this is 5 square plus, so 5 square on one hand and 14 minus 9 and 14 plus 9, right? So 14 minus 9, okay. So I should add not 81, but 25. 25 here. Now does it add up? 9 plus 5, 14, 22 to carry. 14, 6, 842, was that right?
So even I got this, but in the answer scheme was 742.
Yeah, even
Uh,
I got 842. I think the answer scheme's wrong.
I'm sorry, guys. So maybe again, this is I picked up from some of the Asian Olympiads. Maybe either I copied it wrong or maybe they were so wrong. There are generally mistakes in Asian Olympiad answers. Okay, but yes, 842. Now the cosine rule or the sine rule that Siddharth and Moksh were suggesting. So yeah, Siddharth, you want to explain what did you do there for that? So who was that? It's sine rule. Oh, Moksh, was that you? I forgot who
It was me and someone else, I believe.
Yeah, go ahead, Moksh. What did you do for the sine rule, cosine rule?
Okay, so half AB sine theta equals 84.
Okay, so
Half
half
into 14
into 14 into 15 into sine theta is 84. Okay, therefore
Yes.
sine theta is
4.5.
12 upon 15, which is 4 upon 5. Okay.
Yeah. So we know cos theta is plus minus 3.5.
So this angle, so this theta, which can be an acute angle or obtuse angle. So sine is positive in both quadrants. So that sine theta is 4 upon 5. Yeah, and therefore
cos theta is plus minus 3/5, which are the two cases.
Plus or minus 3, 5. And then you use cosine rule.
There's a more efficient method slightly.
Mhm.
So like in the first a squared plus b squared minus 2ab cos theta. Let's say cos theta is 3.5. So in the first triangle, it'll be a squared plus b squared minus 2ab into 3.5, and the second will be a squared plus b squared plus 2ab into 3.5. And the
Anyway,
thing
they'll
is,
cancel.
they just cancel out. You don't even need to compute them. It's just 2 bracket open a squared plus b squared.
Correct. So 14 square plus 15 square plus 2 into 14 into 15 into 3 over 5. So these two will anyway cancel. And therefore, it's 15 square plus 14 square, double of that. Is that what you're saying?
That is correct, yeah.
So 225 plus 196 is got double. And that comes out to be this answer, 742 over.
Yeah, the same one that Tisha got.
Okay. Now that makes me wonder, then the altitude information is not even needed, that means.
Yeah,
because
it's not needed.
We're just doing with 14 and 15. That makes for another beautiful question.
So
right?
I did this with Heron's formula.
But using the altitude, right? Using the area.
Yeah.
Using the area. Okay. No, but looking at what Moksh just called out, since anyway cos theta will cancel out, it seems like if length of two sides of a triangle are given, then we can find the sum of the squares of the possible lengths of the third side. Yeah, that's very interesting. Okay. Okay. Yeah. Good. Heroine's formula. Yes. Ritisha. Yeah. Go ahead, please. So you said
There was a bit of long working, but I got a quadratic and then minus b by a was the sum of the roots.
I see. I see. But it did match with the 842 or 742.
Yeah, I got 842.
842 as well. Okay. But to do the Heroine's formula, you assume this is C and then the 29 plus C by 2. So you'll have lot of terms which the S will have the C. Every term will have C in it, right? So it'll be a fourth order.
No, it's power 2 only.
So sometimes we'll probably cancel out.
It was the sum of squares, so the fourth order becomes second order.
Okay. How so? I'm just curious. So 29 plus C by 2 is your semi-perimeter. So now S into S minus A into S minus B into S minus C. This is S. When I do S minus A, that becomes how much? 1 plus C by 2.
Yeah.
And then S minus, the other one will become minus 1 plus C by 2. Right? And then we have 29 minus c by 2.
Yeah.
Correct?
And
So,
then there was 29 minus c square, so that
so
8
29 square minus c square into,
and
again, c square minus 1 square or something.
and then you can substitute c square as the answer only because it's square.
Okay, all right. It's a fourth order, but it only has
Yeah.
fourth, second, and 0. And therefore, you can say c square equal to d and solve. And then the sum of roots will give that answer. Okay, excellent. Very nice. Yeah, so just so that the last step in case it was not clear. So basically she said, so this divided by, how much is this? 16, right? So this was 84 square. 84 square. So the fourth order equation that she has is whatever, c power 4, blah, 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 something c square, and then plus some constant, right? So plus some constant d equal to 0. Now she's looking for, there are two solutions for the third side c, c1 and c2, right? So the solutions are c1 square and c2 square. If she's converting this to a quadratic, if she's keeping c square as x, so she's trying to solve this quadratic. So the sum of roots of this quadratic will just be the x1 plus x2, which is c1 square plus c2 square. Okay, I'm sorry, guys. I'm just very clumsy, but you guys are very, very fast anyway, right? You will understand this. So x1 plus x2, the two roots are the c1 square plus c2 square, which is just this guy essentially here. And that comes out to be 842, looks like. Very nice. So 3 different methods. And yeah, this is another learning for me that you didn't even need the area iske liye. Because anyway, whatever the cos theta is, it'll get cancelled. But it's surprising to me, if two sides are given, that means, okay.
So
okay.
you do need the area though, right?
Yeah.
Where are you using the area here?
Because you are using the area to calculate the value of sine theta.
But why do you need sine theta? Anyway, the cos theta are getting cancelled, right?
Oh,
That's what I'm saying.
Good point, yeah.
14 square plus 15 square, 14 square plus 15 square. Anyway, they're getting cancelled. Yeah, does it make sense? I mean,
Yeah,
Mox,
that makes sense. That
speaking
makes
to the
sense.
courier, you are the one who suggested this, and he said it's efficient.
That makes sense.
This
Yeah.
gets cancelled. So ultimately, we didn't need the 3/5 at all, which means we didn't need the 4/5 in the first place, which means we didn't need the 84 in the first place. So just with 14 and 15, we could have solved the question. Nice. Okay, next time. Cool. I'm enjoying this multiple ways. Question 10. Rahil.
I didn't get this.
Should have been okay, right? This one. Arnav, what about you? Did you? Whoever is not camera on, please, guys, turn it on. Moksha, Arav, Arnav, Siddharth. Did you guys get Hover got 20? 20, I think, right, was the answer. I think that was right, if I remember. Ritisha, you got this. Anika, you got this.
Yes, I got 20.
Okay. The length of the altitude of the third side must be x. So half into 36 into, let's say the altitudes are, okay, this is A, B, and the, okay, let's say the altitudes are A, B, and C, the third altitude. So half into 36, oh, no, maybe let's keep the altitudes as P, Q, and R. Okay, so let's say this is P. Okay, so the sides are A, B, and C, and the altitudes opposite to them are P, Q, and R, let's say. So this is my P, and correspondingly, the other one is Q and R, let's say. Okay, so half into 36 into A is same as half of 45 into B is half of the third altitude, which is R into C. And each of them is the area, right? So which means, so 2A by 36 is one side, 2A by 45 is the other side, and 2A by R being the third altitude, is the third side, right? Now he wants the maximum possible value for X, right? Third altitude must be greater than X, right? So, length of them must be greater than X. So in other words, he wants the minimum possible value for X. So we know that C has to be bigger than A plus B. Any side has to be bigger than the sum of the other two sides, right? So we have
A
essentially, yeah, sorry.
C has to be less than A plus.
Less than. C has to be less than A plus B. Okay. So therefore, the 2A will get cancelled. So 1 by 36 plus 1 by 45 has to be less than 1 over R. And that's it, right? So 36 into 45, if I reciprocate this, 36 into 45 by 36 plus 45 should be greater than R, right? So the minimum altitude is this figure. So whatever this is, 36 plus 45 is 81. So 9 goes 9 times, 9 goes 4 times, 9 goes 5 times. So R is less than 20. So how is the question worded? Length of the altitude must be greater than X. Why am I getting the... did I mess up the signage? Length of the altitude must be greater than X.
Even I was getting that it should be smaller than X.
Length of altitude must be greater than X. Am I right? What am I doing? 1 by 36 plus 1 by 45 is less than... No. I messed up the signage again. I put A plus B on this side, right? So 1 by 36 plus 1 by 45 is your A plus B. So I'm saying A plus B is greater than C, right? The sum of the two sides must exceed the third side. And therefore, the signage gets flipped one more time here, right? So, do baar galti hui, right? So R is... Are you guys okay on this one? So 1 by 36 plus 1 by 45 is the sum of the two sides that must exceed 1 by R, right? Or rather a scaled version of the sum of the two sides. So this is 45. Okay, let's do it one more time. So 45 into 36 is greater than 1 by R. Now, if you reciprocate, we get R is greater than 81, or rather 45 into 36 by 81. So which works out to be the 20 that we got. So R is greater than 20 indeed. Yeah. Yes, so maybe you also did the same mistake in the signage, right? That's fine. Agreed, right? No problem. All okay. Question 10, that was question 11. Okay, who can I give this one to? Siddharth, were you able to do this? Question 11 in the area of CBP.
No, sir. Actually, I couldn't do this.
Okay. Dipra?
So I haven't solved the
Oh,
set.
you didn't solve after question 8 or 9, I think you said. Or was that someone else?
No, that was me only.
Okay. Okay, Ritisha, how about you?
I didn't get this.
Okay, Anika?
Yes, I did get it. I'll just tell you, my diagram is actually very heavily annotated. I'll just have to look a little.
Fine. Okay, it's okay. In the interest of time, let's discuss, right? So one standard thing, just a recall, if I have a circle, if I have chords intersecting, so if I have a chord, this chord, and another chord like this, okay? So, oh my God, this control button, man. So let's say this is A, B, C, D. So one main thing you should know is AP into PB is CP into PD. Okay, and this results in two similar triangles. This triangle is similar to this triangle, and you can see that clearly because vertically opposite angles. So this angle is equal to this angle, and then angles in the same chord will be same. So this angle will be same as this angle, and therefore naturally the third angle will match. So this angle will be this angle. And the interesting thing is it works out even if the intersection happens outside the triangle. So if I have the two chords intersecting outside, the same logic. So let's say this chord is here and this chord is here. Okay. And then when you extend, they meet here. Okay. So it's still the same logic. So this is A, B, and C, D. And let's say this is P. Then AP into PB is CP into PD, right? You go to the intersection point and then you come back to the other end of the chord. So we'll use that logic here. That's what is happening. The A, B, and CD are meeting outside the figure here. So let's mark all of these lengths. So this is 32. and this is 10. Okay, and CD is 64. Okay, let's call this as CP as X. Okay, so AP times, so let's do this. AP is 42. 42 into 10 must match my 64 plus X into X. So I can solve for X from this, right? So the quadratic is X square plus 64X minus 420 equal to 0. So that's 70 and 6. X plus 70 times X minus 6 equal to 0. So this becomes 6. So now I get this as 6. So PC is 6. Now, the area of triangle ACD is given as 672. Okay, ACD is given as 672. So 64. Okay, now we know that if I have a scaled version here, okay, so this is 6. If I have this triangle, okay, so let's look at the triangle PBC and the triangle PDA.
In this, actually, there is a easier way to do it.
After arriving at PC as 6, is it? Or even before that?
After arriving at, like after getting PC equals 6.
Okay. Just hold on 1 second, Anika. I want to make sure. So these two are similar. These two are similar triangles, right? You can see that the ratio is 6 and 10, right? And so this is 42. So this is 42, right? So PB is 10. PB is 10, and PD is 70. So that's 1:7, and we can see the same ratio as PC. So PC is 6, and then this is 42. PA is 42. So we can see that these two triangles are similar only, right? Essentially, this angle matches this angle. So angle between and then this angle is common. The two upper angle is common, and then this angle is matching this angle. Okay, so in other words, area of this triangle is scale factor is 1:7, right? So I'm getting confused now. Which is given to be 672? 672 is which one? ACD is given to be 60. Oh, okay. We don't need to do so much at all. So this is given to be 64, right? So we can just draw the altitude here. Okay. So half into 64 into, let's say this is H, is 672. So I can find H. H is how much? 672 divided by 32, which is 21. So this is 21. Okay, so which means this, if I drop a perpendicular from here to here, from B, if I drop a perpendicular, right? So these two triangles are, so let's mark this as X. Forget the similarity, what I told here, that's not even relevant. You don't even need this, right? So if I look at PBX, okay, the small right angle triangle PBX and the big right triangle PAY, let's say this point is Y, PAY. These are similar. They are two right angle triangles. And the ratio is PB is 10, whereas PA is 42. Am I right, guys? 6 and 10 and 42. Okay, so which means if the altitude is 21 here, the altitude is 21 here, the altitude of this becomes 5. So it becomes half into base into height, half into 6 into 5, which is 15. Sorry, I went a little fast. Let me just explain once more. Anika, after that, I'll hear your answer, which is more efficient. Okay, so till this part is clear, right? Till we got 6 that was needed. Now I'll just call this as Y, and this length was 64. This length was 64 from here to here. CD was 64. Okay, so all I did was I dropped a perpendicular from A to CD and said the area is half into 64 into H. The base is 64 and the height is H and the area is 672. So using that, I figured that the height is 21. So this height is 21, H is 21. And now I drew a parallel line from B. So that's this parallel line. I'll draw this in another color. This parallel line, which is also 90 degree, right? That's the altitude of this small triangle here. This is X. Sorry, X is here. This is C. C is this point on the circle. X is where the altitude was falling. In this case, it's falling outside the triangle. So you can see this triangle, something like this, right? So I have to draw this triangle. This is how it's looking like. So this is my B, this is my P, and this is my C, and the altitude is falling outside here like this. Okay, so this is 90. Okay, so and then I said this by similarity, we got this to be what, 6 or 5 rather, right? Because the ratio is 10:42. Therefore, the altitude ratio is also the same ratio, 5:10, 5:21, and then half into base into height. Sorry, is this clear? Ritisha, is this clear?
I did it till the altitude part, but I didn't see the similarity.
Sorry, you did it till the altitude part?
Yeah, but I didn't see the similarity between them.
Okay, but now it makes sense. Okay, okay, Anika, what did you do after finding the 6?
Yeah, I did almost the same thing after getting 21 and 6. Instead of doing similarity, I just took the perpendicular from C to BP. So half into like 42 into that, whatever H is equal to half into 21 into
Okay.
6.
Fine.
So
So you drop the perpendicular from C
yeah,
instead of from B. That's the only difference.
and yeah, that's it.
Okay, cool. Okay, all right, next one. Which one was that? Question 12. Question 12.
So can I tell you how to do that?
Yeah, go ahead, Siddharth. Oh, no, okay, no, not question 12. I think we are missing, or did I mislabel? Question.
Yeah, there are two question
There are
levels.
question levels. Okay, yeah. Yeah, you want to do the complex number? Yes.
Yeah, so in this, you have to just use a complex number conjugate theory. So if one root is minus half plus root 5 by 2i, the other one will be minus half minus root 5 by 2i. And
When does that happen? So the roots are conjugate when? When does that happen?
So when there are complex numbers, they always occur in pairs. So
it is correct, but you have to complete the statement. Not always that's the case. Yeah, Rahil.
Is it when the coefficients are real numbers?
That's very important. If the coefficients are real, then if at all there are complex roots, they'll appear in conjugates. And in this case, they are definitely real. Why real? They're even integers, right? Which is more than what you can ask for. Yes. And therefore, the other Jodi of this must be minus half minus root 5 by 2i. Okay, and then continue.
Then we can use the sum of roots formula that will give us minus 16 by 8, which is minus 2.
Yeah.
And then the sum of the complex is already minus half, which is minus 1. So the other is minus 1. So the real roots ka sum is minus 1, and they have asked for the positive value of that. So that is 1.
Exactly. So sum of the 4 roots is minus b by a, so which in this case is minus 2. The 2 complex roots, which are conjugates, add up to minus 1. Okay, and then find the absolute value of the sum of the real roots of this equation. Okay, we are assuming the other 2 roots are real, right?
Yeah.
What if the other 2 is also complex? But the fact that it's asking find the sum of the real roots of this equation, we can only assume that the other 2 roots are real. Or we can actually divide and just check, which is not needed. Okay, but yes. So the other 2 add up to, so minus 1, and then the other 2 must add up to minus 1 as well, so that the sum of all the 4 roots is minus 2.
Yeah.
Yeah, cool. And then he wants the absolute value, as you rightly said, it's plus 1. Therefore, okay, cool. Question 12. Rahil, were you able to do question 12?
No, sir, I am not right.
Okay. Moksh, question 12. Moksh, I don't see he's around.
So question This I was not able to do.
Not able to do. Okay. Who else? Ritisha, are you able to do this?
I got 3032 as the remainder for some reason.
3023 as the remainder.
3032, I don't know why.
But the remainder is a linear function, right?
Yeah, that's wrong. I got 3032.
Okay. Anika, what about you? You got the correct answer on this one, B by A.
Not, I left the last two questions. I did not have the time to finish.
Okay. All right. So let's do. So when you divide by a quadratic, in general, the remainder can be a linear, right? So whenever you divide by x power n, the remainder is of the order of x power n minus 1. When you divide by a cubic, the general remainder is a quadratic, and so on. So in this case, what are we saying? F of x, when you divide by x square plus x minus 2, you get some quotient. So so that, let's say the quotient is some q of x, doesn't matter. And then you get a remainder r of x. And like I said, the remainder is a linear function in this case because the divisor is a quadratic. So the remainder r of x, okay, in fact, let me write r of x. And r of x is a linear function in this case. So this r of x is your ax plus b. Okay, now, so an x square plus x minus 2, we can clearly see that's x plus 2 times x minus 1. So we have x plus 2 times x minus 1 times q of x plus ax plus b is your f of x. Okay, so clearly, in fact, this is how the remainder theorem and factor theorem come, right? So when you say f of a is the remainder, it's because of this. So if I put f of 2, f of minus 2, rather, right? F of minus 2. So f of minus 2 becomes, this quantity becomes 0 because of, right? So it becomes minus 2a plus b. So f of minus 2 becomes minus 2a plus b. And what is that? When I put minus 2, it becomes minus 2 power 2023 plus 2 times minus 2 power 2022. And he has constructed it beautifully. This guy cancels off exactly with this. So minus 2 power 2021 will cancel off with, this will be a positive quantity again because of the even power. So we'll get bunch of cancellations, all the way till this will become minus 2 plus 2, which is 0. Okay, so minus 2a plus b is 0. Now, similarly, let's put the other f of 1. Again, this will be 0 because of this guy. So 0 plus a plus b. And if I put f of 1, what do I get? I get literally the sum of all these coefficients, right? So it's 1 plus 2 plus 1 plus 2 and so on, right? 1 plus 2 plus 1 plus 2 and so on. So for every pair, I'm getting a 3. So how many pairs there are? So 2023 minus 0. So sorry, there are 2024 terms. So 2024 terms starting from x power 2023 till x power 0. So there are 2024 terms, which means there are 1012 pairs, and each pair is getting added up to 3. So the sum is 3036. So this is 3036. And now we can clearly solve for a and b. So I can just subtract. So 3a is 3036, a is 1012, and b is 2024. And therefore b by a is 2. Is that the answer scheme say 2, right? Or does it say something else again? Which one? Oh, yeah, question 13, was it? Okay, maybe it's off by 1 because of that copy paste error. But yeah, it says 2, right? Does it make sense? Whoever didn't get it? Ritisha, make sense? Okay. All right, so that's question 12. Question, is it the last one? Question 30 is the last one? Okay. Question 13, who wants to go? Rahil? Rahil is there?
I have no idea how to do such a problem.
Okay. Who else? I've only had a few people who have been answering. Dipra, can you try this? Or did you get this?
So I hadn't solved the second half.
Oh, okay. Yeah. Sorry, I keep forgetting. I'm sorry. Okay, I'll open it up to anyone. Again, I'm not sure the answer is right. Could be wrong or be right. I'm not sure. Because I remember doing it, I got 29, but maybe I did it quickly. Oh yeah, I think no one has done this, you said, right? Okay, let's do it together.
So I'm getting 49.
49.
Yeah.
Okay. Okay. I got 29 when I did it quickly, but looks like answer is 27. Let's figure out. Could be answer is wrong. So I'm not trusting all their answers. It could be 49 also, like you got. Let's see. Let's do it properly. Okay, so what does he say? This is a 7-digit number. How many twos? 2, 2, 2, 2, 4 twos, 1, 3, 1, 0, and 1, 5. Okay. The sum of all such 7-digit numbers, each of them is formed, blah, 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 is n. Find the sum of the digits of n. Okay, so first of all, he must clarify one thing. 7-digit number cannot start with 0. So you cannot start a number and say this is 7-digit, right? That's not valid. Okay, so let's assume, go with that assumption. Okay, so now if I take any digit, okay, so let's take, let's say 2023. Let's take this example itself, 2023, 225. Okay, so how many numbers are there in total? In how many ways you arrange numbers? The first number, first digit can be any one of these, average of this.
So it's just 7 factorial over 4 factorial, right?
7 factorial over 4 factorial, but you cannot have 0 at the first.
Oh yeah, okay.
Right, that's what. So 7 factorial or 4 factorial, if you have, so 7 into 6 into 5, how much is this, guys? 210. Okay, so 210 is the number of numbers you can have, assuming 0 can be at the beginning. But this will have some numbers with 0 at the beginning, right? How many of them will have 0 at the beginning? If I put 0 at the first place, if I intentionally put 0 at the first place, then
6
it'll be
factorial,
6
right?
factorial upon 4 factorial, right? Am I right?
Yes.
So 6 into 5, which is 30. So there are 180 numbers. Okay. 180 numbers. 1, 2, 3, 4, 5, 6, 7. Okay. 180 numbers. Okay. Now, if I look at the leading digit, so this 1, 2, 3, 4, 5, 6, 7. If I look at the leading digit, so it can be either 2, 2, 2, 2, or 3 or 5. That's it, right? Only one of these 6 digits, right? So we can say with equal probability, it'll be one of these entities, right? Like I can treat this 2A, this is 2A, this is 2A, 2B, and 2C, and 2D. So roughly, not roughly, exactly 1/6 of them will begin with 2A. Exactly 1/6 of them will begin with 2B. So to say, right? As if I mean it, differentiating between the twos, right? So the 180 numbers, the leading digit will add up to 30 numbers with 2A, 30 numbers with 2B, and so on. So there's effectively 120 numbers which start with 2, right? And 30 numbers which start with 3, and 30 numbers which start with 5, right? So what is he wants the sum or the average? Find the sum of the digits of n. What is n though? Oh, the sum of all such 7 digits. The sum is n and finds the sum of digits of n. Okay, so if I look at this leading digit itself, the sum of all of those numbers is this figure. So how much is this figure? In fact, I'll write it as 30 times 8. So it's 30 times 8 plus 3 plus 5, which is 16, right? So the sum of the leading digits is 480. Okay, and the leading digit has a value, right? This is 10 power 0, this is 10 power 1, 10 power 2, 10 power 3, 10 power 4, 10 power 5, 10 power 6, right? So it's 480 into 10 power 6 is the sum of this, sum of the leading digits. Okay, now everywhere else it's going to be, you have to accommodate for the fact that 0 can also be involved in this, right? So of the, okay, let's say the leading digit is 2C. If the leading digit is 2C, right, And that there are how many of them you said? There are 30 of them, right? 30 of them with leading digits as 2C, right? So these 30 for the second digit, 0 also can come, right? So 1/5 of those, or 1/6 of those will begin with 0. 1/6 of those will begin with 2A. 1/6 of those will begin with 2B, 2D, 3, and 5. So if we look at the second digit, right, it's an equal distribution between 0 and the 5 other digits, right? So what do these add up to? So 0 will come in how many of them? So we can count that a little more efficiently. Just messing it up a little bit, looks like. Or should we include the zeros first and then subtract all of those? I'm just thinking whether we can treat 0 as any other number and then equally distribute it, and then we can subtract off those cases where it begins with 0. I think that might be easier, guys. Okay, sorry. Otherwise, dealing with this is a bit of a problem. Okay, so same logic. All I'm saying is, let's start with the 210. Let's not subtract the 30. So there are 210 numbers, some of which will begin with 0, right? But no problem. We'll give 0 equal status. Okay. So for each digit, so there are 2, 2, 2, 2, 0, 3, 5. So with equal distribution, we'll have each of these digits. So how much do these add up to? 8 plus 3 plus 16, right? So 16 is the sum. Okay, and each digit occurs 30 times, right? So 16 into 30, 480. Okay, 210 divided by 7 is 30. So essentially what I'm saying, 30 numbers will start with 2, 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 30 numbers will start with 0, 30 numbers will start with 3, and 30 numbers will start with 5. So this sum is 30 into 16, 480. And same for every single digit. So 480 times will become 10 power 6 plus 10 power 5, all the way till 10 power 1 plus 10 power 0. So that we can do. So 480 into whatever, 1111, 111. We can figure out that number, right? That will be the sum of all the numbers, including those where 0 is the leading place, right? Now, we just have to subtract from this those numbers where 0 is in the leading place, because we are not accounting those numbers at all, right? Those are not valid numbers. So we'll have to subtract those numbers. So if 0 is in the leading digit, that means we have 2, 2, 2, 2, and 3, 5 in the remaining 6 digits. So how many possible numbers there? So 6 factorial by 4 factorial, as we just saw, right? Which is 30 numbers, right? And 30 numbers and equal distribution between the 6 digits, right? So 5 of them, okay, so 5 of them will occur with 2, 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 5 of them with 3, and 5 of them with 5. Are you guys with me? So there are 30 numbers with 2, 2, 2, 2, 3, and 5. And then for each of the digits, it's equal distribution. Therefore, this will be 5 times the same 16, which is 80. So we'll have to subtract 80 into, this is 10 power 5, right? So which is effectively 80 into one less number of 1. 80 into 1, 1, 1, 1, 1, 1. So we just have to subtract 480 into this number minus 80 into this number. That will be the effective sum, uska sum of digits. Does this make sense, guys? Okay, Dipra, does this logic make sense to you?
Yeah.
Okay. Maybe there's a slight bit of efficiency you can do, but I don't think more or less it will work out to the same thing. Okay, and you guys can finish it off, right? So I'm not going to do this multiplication, right? And then see if the answer matches, guys. If you can, please. We are end of time here. I have to go for another thing. Okay, so let's stop here for today. Just check your answer by doing this, and then we'll discuss tomorrow again, tomorrow afternoon. Okay, thank you. See you tomorrow.
Bye, sir. Thank you,
Bye.
sir.